Hi, and welcome to another video with Mr. Weiss. Uh, this one will continue on scientific notation, where we'll work on 10 scientific notation problems together. So let's get right into it. So the first one, the human eye blinks an average of 4,200,000 times a year. So to turn this into scientific notation, we understand that the decimal point, we can write it out over here if we want, we understand that the decimal point is right here, so we're just simply going to move it over between the 4 and the 2. So we're going to move once, twice, 3 times, 4 times, 5 times, and 6 times. So we simply write it now as 4.2 times 10 to the power of 6. Let's move on to the next one. So this number we have here is: a computer processes a certain command in 15 nanoseconds. Now a nanosecond is 1/1000th of a second. In decimal form, this number is 0.000000015. So we need to get this decimal point over to this point. So we're going to move it once, twice, 3 times, 4 times, 5 times, 6 times, and 7 times. And I seem to have missed a number, so it's actually 8 times. So we'll just add that in there, 8 times. So we'll simply write that now as 1.5 times 10 to the negative, because it's a small number, it's -8. We can move on to another one. There are 60,000 miles, or 97,000 kilometers, in blood vessels in the human body. So we'll take this first one here, 60,000. We could do it over here, or we can do it just on there, but let's just keep going with this for now. So it's 60,000, write it out. Decimal points right here, move it once, twice, 3 times, and 4 times. 4, 6 times 10 to the 4th. Oh, sorry, looks a little off there. Let me fix that. Six times 10 to the 4. So the other one is 97,000. So we can see that 60,000 is already 10 to the 4, so we could just extrapolate that and seeing how it's 9.7 times 10 to the 4th. The next one, the highest temperature produced in a laboratory was 920 million Fahrenheit, or 511 million Celsius, at the Tokamak fusion test reactor in Princeton. So we can write this one out again. 920 million. And we can see here we're going to move the decimal point once. Sorry, I think my audio kicked out there. 8 times. So we simply write that now as, over here. 9.2 times 10 to the 8th. And because they're both in the hundreds of millions, we can just extrapolate it again and write it as 5.11 times 10 to the 8th. Now, this next number is again really a small number. I don't think it'd be beneficial to write it all out. So what we can just do is we can count the sets of zeros and then just essentially times it by 3 is what you're going to do. So I'll show you here what I mean right now. So this first set once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, and 8 times to get the decimal point over here. So 8 times 3 is of course 24. So we simply write now as 1.673 times 10. Now it's a small number, so it's negative 24. We can do the same thing with this next big number. We'll just count the sets of 3 or moving it over. So we're having to get the decimal point over to between the 1 and the 9 here. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So of course 11 times 3 is of course 33. So we can write it as 1.989 times 10 is a large number, so it's positive. So 33 grams. So the mass of the sun is approximately 1.989 times 10 to the 33 grams. The next one, the cosmos contains 50 million galaxies. So we're just going to take the number here and we'll move it over. So we have 3 sets here plus 1 more. So it's going to be 10. So we'll write it out as 5 times 10 to the 10th is the number of galaxies in the cosmos. The next number, a plant cell is approximately 0.00001276 meters wide. So we're simply going to move it over once, twice, 3 times, 4 times, and 5 times. So we simply write as 1.276, because we need to keep all those numbers, times 10 to the small number, so negative 5. These last 2 ones were given, the numbers we are given is in scientific notation, so we need to transfer that over to standard form. So 4.5 times 10 to the 9th, so we can do it. All right, where'd my cursor go? Oh, there it is. We'll write out 4.5 here if we want, and we're going to move it once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times. Fill it in. Fill in all the zeros. So that is 4.5 billion years old. Just write out here. $4.5 billion years old. Now, this next one is again a very, very small number. So we can take 1.6 times 10 to the negative 27. So that's going to be, because we're taking, if we write out 1.6 here, 1.66, we're going to move it once, right? We're going to move it once, and then we need to add another 26 times. So all we have to do is add 26 zeros. Do we understand that? Because we need to move it once to get out on the other side of the 1, and then another 26 times. So we need 26 zeros. So we're going to write out here 0 point followed by 26 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So we have our 26 zeros here, and now we can add the 1, and the 6, and the 6. So we know, and then of course it's in kilograms. So that is the answer to the last one, this bottom one right here, 0.26 zeros, and then 166 kgs, which is the weight of one atomic mass unit. Thank you for watching the video.